After the contactor, we will be adding a heat exchanger and a distillation column. The distillation column will model a regenerator, which is used in industry to regenerate the solvent. Solvents used in industry are expensive, therefore regenerating a solvent is essential to the benefits. We will change the default specifications of the column and look at the different tabs available to the user. The rich TEG stream is flashed across a valve, so we add a valve. Specify the inlet stream as rich TEG and outlet stream as LPTEG. We do not enter the pressure drop or outlet pressure for this valve, as the outlet pressure will be retroactively calculated. Add a heat exchanger to heat the rich TEG stream by a hot lean TEG stream from the regenerator. Enter the heat exchanger name as LR hex. Tube side inlet as regen bottoms. Tube side outlet as lean from LR. Shell side inlet as LPTEG. And shell side outlet as regen feed. In the Design tab under the Parameters page, specify the tube side delta pressure as 10 psi and the shell side delta pressure as 0.3 psi. In the Worksheet tab, specify the temperature of regen feed to 220 degrees Fahrenheit and specify the pressure of stream regen feed to 16 psi A. Note: the valve is converged as its pressure is back calculated by the heat exchanger LR hex. The TEG regenerator is simulated as a distillation column. The TEG regenerator consists of a condenser, a reboiler, and 3 ideal stages. Therefore, we need to add a distillation column to the flowsheet. Enter the distillation column name as TEG Regenerator. Specify the stage number as 3 and change the condenser type to full reflux. Connect the inlet stream as regen feed, the overhead vapor outlet as wet gas, the bottoms liquid outlet as regen bottoms, the condensed energy stream as conq, and reboiler energy stream as rebq. Click Next to go to the reboiler configuration step. We need to accept the default choice. Click Next to go to the pressure profile page. Specify the condenser pressure drop to 0.15 psi, the condenser pressure as 14.7 psi A, the reboiler pressure drop as 0.15 psi, and the reboiler pressure as 15 psi A. Click Next. Since we do not have good estimates for temperature, we do not input values on this page. Clicking Next will bring us to the specification page. Now, click Done to complete the installation of the TEG Regenerator, since we would like to input the specifications on this page later. We will add 4 specifications to make the column converge with our requirements. We want the vapor condensed at 215 degrees Fahrenheit at the top of the column. To specify this, navigate to the Design tab, then the Specs page. Delete all the default specifications, then click Add, scroll down, and find Column Temperature. Highlight and click Add Specs. Change the name to ConTemp and select the stage as condenser and specify the spec value as 215 degrees Fahrenheit. Then close the temp spec view. Repeat these steps to add another temperature specification, which is used to require that the column converges with the reboiler temperature at 400 degrees Fahrenheit. Then add a third specification, column reflux ratio, and specify its value as 1, and the flow basis as molar. Add a fourth specification, column draw rate, to estimate the draw rate of the stream wet gas to be 1 kg mole per hour. Then go to the Design tab a monitor page to check the status of the specifications. Unactivate all specifications. At the bottom right corner of the monitor page, you will find that the degrees of freedom is 2. So we can activate 2 specifications. Select contemp and reptemp and set other 2 specifications as estimate. When the column converges, the algorithm will try to meet the condenser temperature as 215 degrees Fahrenheit and the reboiler temperature as 400 degrees Fahrenheit. The value of the reflux ratio and draw rate are estimation specifications and serve as initial estimates for the convergence algorithm. Go to the Parameters tab, the Solvers page, then change the damping factor to adaptive. This will result in a much faster convergence for this column. Then run the column. The column converges in seconds.